So the Algebra 2 semester exam is going to cover chapters 1 through 5, but just up to 5.3, okay? Now, I really don't know yet. We don't know if we're coming back in person on the 4th or if we are starting back up our hybrid schedule. So I know for sure we will be reviewing the week of January 4th, and then we will be taking the test sometime on the week of the 11th. So once I know a little bit more about our schedule, I'll give you exact dates. So those dates you see there are kind of if we meet hybrid, but I don't know yet, okay? Okay. So I'm going to break this review up into two parts. It's at the bottom of your chapter 5 note sheet. So that's where you're going to find these problems to do along with me. So let's start with number 1. Now this pretty much follows what you're going to see in the chapter, from chapter 1 to chapter 2, so it kind of does follow that order. So first, let's start with number 1. Order of operations says that we should do the parentheses first, then the powers. Now anything to the 0 power is 1. Then any multiplication or division from left to right. So there's a division here we should do. And then we add and subtract from left to right. So our final answer will be 12. Let's take a look at number 2. So we have this outer parenthesis. So we look on the inside of it as if it's its own unique problem, and we see an inner parenthesis. So let's ignore the outer stuff, and let's focus on the inside. So we're going to do 8 plus 2 times 2 squared plus 7. Now we next have to do the 2 squared. Order of operations tells us the next thing in that parenthesis we're going to see is the squared. So we're going to get 8 plus 2 times 4 plus 7. Now we have to do the multiplication inside. So that's going to be 8 plus 7. 8 plus 8 is 16. 16 plus 7 is 23. So that's just going to be negative 4 times 23. And then negative 4 times 23 is negative 92. So there's number 2. Now number 3, we're going to do some substitution into our expression. Any place we see an A, they told us the value is negative 2, and the B value is 5. So let's take out the A, put in a parenthesis, and put in a negative 2. Let's take out a B, put in parentheses, the 5. Now, this separation of this fraction means we need to get an answer before we divide by 2. So 6 times negative 2 is positive 12. 4 times 5 is 20. So we're going to make that a 32, and then divide by 2 for a final answer of 16. So there's problems 1 through 3. Now let's take a look at this one. It says find the mean of the following set. The mean, remember, is just the average. So we're just going to add them together. Now there are 4 items in our list, so we're going to divide by 4. So 12 plus 15 plus 10 plus 9, get that total before you divide by 4. And our answer is 11.5. Now if they use the word mode, remember that is the value that appears most often on the list. There is no mode, there is a mode of 9, because the 9 appears most often, it appears twice. The median cannot be determined unless we put the items in order, so let's put them in order for a second. The middle item is the median. when arranged in least to greatest order. So there's number 9. Now let's talk about some equations to solve for 10 and 11. For problem number 10, let's combine the w's. So I would take each side and simplify it as much as I can before you start moving things around. Let's subtract a 4w from both sides. And then add a 5 to both sides. So now we have the w's to one side, the numbers to the other, and now we could just divide by 2. So our answer is 8. Let's take a look at 11. Subtract 3 from both sides, so you get that x by itself, and then divide by 5. The answer is 4. Now, for problem number 12, they want us to solve for w. So the only one we are going to focus on as a variable is w. We're going to think of everything, okay, if the other things were numbers, what would we do? So let's subtract 2L, that is an L, from both sides. So we get area minus 2L equals 2W, or A, I'm sorry, I don't know what the A is. A minus 2L equals 2W. And then we just have to divide by 2. So we get A minus 2L divided by 2 is equal to W. Now you can't divide this 2 off because the A is also divided by 2. And if you divide that 2 off, where does that leave the A? So just leave it. That's your final answer. Let's look at 13, 14, and 15. For absolute value equations, for the most part, you should expect to get 2 answers. Remember, you have to deal with the positive case and the negative case. The exception to that is problem 13. This is saying that an absolute value, which is always positive, equals -3, which is not true. It will never happen. So this one is a no solution. So if you ever get that, your absolute value equals a negative, after it's all by itself and isolated, if you get it equals a negative, you know that there is no solution. But 14 and 15, we do have to set up the 2 individual cases. So 2x equals 6. Or 2x equals -6. So you have your positive case and your negative case. You solve them both, you should get 2 answers. So this gives me an answer of 3. This gives me an answer of -3. And let's do the same thing for 15. X minus 2 equals 6. That's not, I said it, but I didn't write it. Or x minus 2 equals -6. Each one, to solve for x, you have to add 2 to both sides. So the answers are 8 or -4. And if you plug them back in, you should get correct answers. Okay? So that is 13, 14, 15. Now let's talk about inequalities. Remember, the main rule of thumb is if you multiply or divide by a negative number, you have to flip the symbol. That's the main thing to remember about those. If we look at 16, we immediately are dividing off the -2, so you got to change that symbol the next time you write it. So we get that m is less than +2. Now, if we drew that at 2, we would have an open circle. We want all values less than 2, so we would shade to the left. Let's take a look at 17. Now we're going to solve it just like an equation. So subtract 12 from both sides. Subtraction doesn't change our symbol. Divide off the 7. That doesn't change our symbol. So on our number line, you got to put a 2. But this time, we're going to have a closed symbol because we have an equal to bar. And we're going to shade everything bigger than 2, so that would be to the right. Let's take a look at 18. Now, 18 is considered a compound inequality. You want to get your x in the middle. So what's touching the x is a 2, which implies multiplication. So to get rid of it, we have to divide by 2. But we not only divide by 2 in the middle, but we divide by 2 everywhere. So we get that x is between -3 and 6. Now the equal to implies that it can also equal -3 and 6. So you want to put both of those numbers on the number line, and you want to shade them in because they're an equal to, and then we shade everything in between. So that is some inequality stuff. Let's keep going. Now, if 19 says or like it does, that is just a union of the first piece with the second piece. If it said the word and, the answer would be the intersection of the first piece and the second piece. So please watch that very carefully. Do they use the word or, which you just would be the first piece or the second piece? Or if they use the word and, you have to look at where both pieces intersect. So just watch that. So let's do 19. You're going to solve each one individually. So the first one, just divide by 3. The second one, subtract 2 from both sides. Now all we're going to do to get our answer, you put or between them to remind you, you just graph each one on the number line. Now put them in number line order. Let's start with this piece. We want the y's greater than 3. So there's an open circle at 3 and everything bigger than 3. You know, like 4, 5, 6, 7, 8, which will go to the right. Now this one says we want all y's less than 1, so we would have an open circle at 1 and everything to the left. So that would be 19. Again, if that was the word and in there, we would have no solution because we would be looking for where these two things cross, and they don't. They don't intersect. Let's take a look at 20. An absolute value greater than should be rewritten as an or. This gets our positive case and negative case. So an absolute value greater than is an or. The positive case or the negative case. Now what does the negative case do? Well, it flips all of this. So it makes that become a less than. It makes that become a negative. And now you just solve them each individually. Well, how would you solve them? You divide by 2. So if you divide this one by 2, you get 4. You divide this one by 2, you get -4. And so if we put it in least to greatest order, greater than 4 is an open circle at 4, shade to the right. Less than -4 is an open circle at -4, shade to the left. Or very often does end up looking like two pieces going outward. And that's not always the case, but many times. Now let's go on to 21. Now I want to pretend for a minute. Let's call this 21A, and let's do 21B. Let's do the absolute value is greater than or equal to -2. Or, I'm sorry, +2. Okay, so let's do B first. Greater than or equal to, well, I do, no, I'm sorry, change this. Let's make this less than or equal to. Less than or equal to is an and. It's an intersection. But the easiest way to write, so we're going to do absolute value of x is less than or equal to 2. Less than or equal to is an and. Now you can write the positive case, the word and the negative case, but what I like to do is I like to take off the absolute values, and I like to stick the negative case directly on it. The reason I like to do that is because it does the and as a compound statement, and it just makes it easier. This one's done for us because there was nothing in here that we had to change. You know, it's just an x. So I now know that x is between -2 and +2. So if we graph that, we would have closed circles at -2 and +2, and the answer is everything in between. Okay? Now let's go back to the way that 21 was originally written. Yes, it is an and. But let's just take a moment. Remember we had an absolute value that equaled a negative number and I said there was no solution? This is saying that positive stuff is less than or equal to negative stuff. Now think about our number line. Are positives less than or equal to negatives? Never, never, never. So anytime an absolute value, inequality, or equation is related to a negative, you have to think about what that means. And usually it's either going to mean no solution, or it might even mean all real numbers, that it might work for everything. Okay? So that is 21. Let's look at 22. State the domain and the range of the following, and is it a function? The domain are the set of x's. If any of the x's repeat, don't write them more than just once. So the domain for 22 is 0, 4, and 5. The range for 22 are the y values. If anything repeats, don't write them more than once. So the range is just 3 and 6. Now the question is it a function? Well, all you look at for functions is the x values. If any x value repeats, the answer is no. It's not a function. Here, the zeros repeated, so it's not a function. We didn't care if the y's repeated. We only have to check if the x's repeat. Now let's do the same thing for 23. The domain for this one are the x's, 3 and 5. The range for this one are the y's, 3 and 6. Do the x's repeat themselves? They do not. One is a 3, one is a 5. They are unique and different, so yes, it's a function. So those are the answers for 22 and 23. Let's take a look at one last slide, and then we're going to stop, and we will continue the rest of these problems in another video. So let's look at 24. F of negative 4 means, okay, so first, let me go back. Let's look at this. That means that if I input an x into my function, I square it, multiply by negative 7, and then add 5. So that's what function f does. Now what 24 says is that our input is negative 4. So that's going to be negative 4 squared minus 7 times negative 4 plus 5. It is just the answer to that. Okay? So how do you do that? Well, you just have to follow order of operations. That's going to be 16 plus 28 plus 5, which is 49. Now for 25, we aren't inputting an exact value. We're inputting a new variable, negative b. But we do the same thing. So that's going to be negative b squared minus 7 times negative b plus 5. Now, when we square negative b, that's negative b times negative b. Two negatives make a positive, and the b's make a b squared. In the middle part, we have a negative 7 times a negative b, which is positive 7b, and the 5 wasn't affected, so it just stays along for the ride. So there is the first part from our semester exam review. I hope that helped you remember stuff from the beginning of the year. Thanks so much for watching. You have a good day. Bye.